right, hello everyone. This is Physics with Mr. McQueary, and today we're going to be talking about a topic called measurement. This is a topic that usually you've seen before, but maybe haven't quite thought about it like we do in physics class. There are two main things that we're going to cover today. One is determining accuracy versus precision, and the second skill we're going to cover is determining how to use our measuring devices so that we can get better data. Right? Precision is how close you are each time you do something. So like in archery, you can see our marks we've left. Those marks, if they're close together, are precise. If they're spread out, they're not very precise. Accuracy is how close you are to that right value you're aiming for. All right. That right value is, in this case, a bullseye. Right? So let's look at our first example here. All of our marks here are close together. They're precise, but they're not close to our mark. So they are precise, but not accurate. Over here, the precision is really spread out. None of those are close together. And it doesn't seem like we were very close to our target either. This person's not a very good archer. This person, on the other hand, is an excellent archer. He hits the same spot every time, and it's the spot that he's aiming for. So he's precise and accurate. This last guy over here has a high degree of accuracy because he's getting close to what he's aiming for, but he's not real precise. He kind of misses a little bit high, he misses low, he misses left, he misses right. But he's kind of close to what he's aiming for. So he is accurate, just not precise. These visual representations can be really handy when you're learning a new topic, to look at things from a picture view instead of always with numbers and definitions. Let's look at a few more. All right. Precision, remember, is how close you are. Are these close? Not really. But are they accurate? Are they close to our bullseye? Not really that close either. And B, they're pretty close. They're precise. But they're still not very accurate. He still hasn't hit that bullseye. C can be a little tricky. They're not very precise because they're spread out. But if you take the average of those places that they missed, they all kind of average out to the middle. So he's kind of accurate. That's the toughest one, I think, of the four. And then the last one, this is our ideal archer. He hits the same spot over and over again, and it's the spot that he wants to hit. All right, now we're going to move on to some numbers. All right, so just like our visual, we can also do this with numbers. So this time, our right value is going to be a number. In this case, it's 3. And then we're going to compare what we measured with that value. So in the first case, 9.3, 9.2, 9.4, 9.3, that's almost like this one over here in B, all right? They're all pretty close to each other, all right? But none of them are near 3, right? You can see they're close together, but they're not really what they're aiming for. On this right side over here, accuracy, we have 3, 3.2, 2.9, 2.8, 3.0. Those are both accurate and precise. That's like D over here. All right, they're all pretty close together, and they're all close to what we're trying to get, the right value. Let's do a few more examples. All right, these numbers over here are pretty spread out. All right, and if we're comparing them to 20, there's a lot of them that are really far away from 20, right? So they're not precise, and they're not real accurate either. These guys over here are pretty clumped together, so they're pretty precise. But 75 and 74 are a lot different than 20, so they're not accurate. C over here, the average is right around 20, but the precision's not good, right? There's a lot of leeway in this, a lot of standard deviation. So not very precise, but you can make the argument that because their average is close, they're kind of accurate. D, on the other hand, is where you want to be. All these numbers are right around 20, and that's the number we wanted to get, right? So they're precise and accurate. All right, so accurate precision, we're doing well so far. This is Ichiro Suzuki. He's a former Major League Baseball player with the Seattle Mariners and New York Yankees. He's going to demonstrate some precision and accuracy for us. Go ahead and enjoy this. So, Ichiro knocking down all 4 of those bats. Let's figure out if that's precise or accurate. Okay? So precision would be how close those are together, right? Are all his pitches close together? They're kind of spread out, right? He's not hitting the same exact bat over and over again. They're about a foot apart, right? But is he accurate? You betcha, because he's aiming for that exact bat every time, right? So Ichiro has that accuracy. All right, now the second thing over here is how to use a ruler. And I know this seems really simple because you've been using the ruler for a long time, right? But it's a good skill to practice anyway. And you're going to find out there's some things maybe you didn't know about this. Okay? So look over here at this ruler, okay? And we have tick marks. There's 10 tick marks between every centimeter. So that means that each tick mark is 1/10 of a centimeter. So we can measure things with certainty down to the 1/10 of a centimeter, okay? So your answer would look something like this, correct? All right, now here's the part you probably didn't know. In physics, we take it a step further and we say, hey, you can measure that to the 1/10 of a centimeter, and then we have this fudge number. It's kind of a guess of what's the closest thing next. Let's do an example here. All right, let's look at Baby Yoda. All right, we're going to measure his head from his ear to his ear. Now, the first thing we need to do is we need to line him up with 0, right? So let's go ahead and scoot him over a little bit. Now we can get an accurate measurement of Baby Yoda's head. We look over here, okay, to the nearest centimeter. We can definitely say that he's between 2 and 3 centimeters. Let's go ahead and fill that spot in. All right, because our centimeter, our ruler here, is to the 1/10 of a centimeter, we can go ahead and fill this next slot in, okay? So we can say that he is 1, 2, 3, 4, 5, 6 tick marks past the nearest centimeter. So we'll go ahead and fill in that 6 as well. Now this is our fudge factor, okay? So after that 6 tick mark, let's try to guess how close he is between this tick mark and this one. So I would say maybe a 1 or a 2, right? If he was an 8 or a 9, he'd be over here, right? So 2.61 or 2 61 thousandths, right? There's one more thing we're missing, and this can be really easy to forget, especially when you're on a test or a quiz, and that is our unit, centimeters, okay? You can tell me 2.61, and I'm going to ask 2.61 what? Inches, feet, elephants? Who knows, right? We need to make sure we convey what our units are. Because a 2.61 centimeter Baby Yoda is adorable. A 2.61 mile long Baby Yoda is terrifying. All right, let's do another example here. How long are these 2 candy canes? And I'm going to go ahead and tell you they're the exact same length. Watch this, though. All right, so ruler A measures in terms of centimeters. So there's not a whole lot of precision in this one. Down here at the bottom, though, we measure to the nearest 1/10 of a centimeter. That's a big difference. We're going to see here why. Okay, ruler B, we can definitely measure to the nearest centimeter. And, well, we can go ahead, well, I guess it's 4. See, 1, 2, 3, 4. After that fourth one, now we've got to guess with our fudge factor here, what's the next digit going to be? I don't know. That looks maybe like a 2 or a 3, right? Let's say 2. Okay, and ruler B, let's look at that. We can go ahead and say with certainty that we can measure the nearest centimeter. So 1, 2, 3, 4, just as before. We can measure the nearest tenth. 1, 2. All right, and then we get to guess one more place. Okay, and it's just past that 2, so I'm going to call it either a 1 or a 2. So you can see it's the same exact candy cane, but depending on which ruler you use, you can be much more precise. With this top one over here, since we've only measured to the nearest centimeter, we can only guess one more digit. Here at the bottom, we can guess one more digit than this, which is instead of a 1/10 of a centimeter, now we can guess to a 100th of a centimeter. So when you study sig figs or significant figures in chemistry, this is what you're getting at. You're saying how precise is that measurement or that tool that you're using to measure? You know, is it ruler A or is it ruler B? Makes sense? So if you have a measurement that has like 10 digits, that means you're going to have a really, really precise instrument. If you have something that's maybe only a couple digits, like this one, then there's not a whole lot of precision. All right. So the 2 learning targets we covered today were determining accuracy and precision, and then figuring out how to use our measuring devices to collect reliable data. I hope you've enjoyed this, and until next time, see you later.